Okay, so do we have any questions on your homework from last night? Page 7, or you had page 8, just the odds. Okay, then I want to start today back on page 8. We're going to talk about the rest of the evens. So we looked at some of the evens together yesterday, or in your notes yesterday, I should say. So I want to talk about the rest of the evens for a little sort of refresher on that function notation. So if I take a look at, we did 2 and 4 together yesterday. Let's take a look at 6. P of 120. Remember that function notation, it starts off with whatever I named my function. So we name them with a letter. So P is just telling me which function I'm talking about. And then that stuff in parentheses is the input or the independent variable or the X value. And then it equals the output or the dependent variable or the Y value. So I've got the X, I want to know what Y it gives me. If I put this X in, what Y do I get out? So for function P, that's our second table here. If I put in 120, I get out 68.1. For number 8, G of -1. So here's function G, this graph right here, G of -1. So here's my X value. My X value is -1. And now I would follow this to wherever it was on my graph, right? As long as I'm on -1, so up or down. In this case, -1 is actually right. That point on the graph is right on the axis. So here I have the point -1, comma 0. So for an X value of -1, my Y value is 0. For number 10, K of 3. K is the second input-output map. I'm saying my input is 3. That gives me an output of 1. So K of 3 equals 1. For 12, P of 40. So here's my input of 40. My output then is 32.5. So P of 40 equals 32.5. And in the notes from yesterday, we did sort of the inverse of that problem. We had 32.5 and we found that the input would have been 40. Questions on the first sort of section of problems on this page? Okay, so for each of these, we had an input and we used it to find the output that matched. In the bottom section, we have an output. We're going to use it to find the input that matches. So for number 16, K of X equals 2. So I'm looking at an output of 2 here. So if I go to K of X, my output is 2. That had to have come from an input of 4. So X equals 4. For 18, I have M of X equals 3. M of X is this mapping right here. I know the output I have is 3, so I can trace that back to the input that I had to have started with, which would also be 3. So X equals 3 here. And then for 20, S of X equals 2. So my output is 2. So if I go to S of X, it's this graph right here. My output is 2, my Y value is 2. So there's 2. I'm going to follow that to my graph. Remember, anywhere that I have a Y value would be here. So that's right here. This is the point on my graph that has a Y value of 2. This is the point 1, 2. So for an output of 2, I would have had to have had an input of 1. So X equals 1 there. There is one problem from your homework that I want to take a look at, and that's number 17. So K of X equals 1. This map right here, our output is 1. What's the input that would give me an output of 1? Yeah, you have to give me both of them, okay? Both of these inputs gave me this output, so I need to list both of them. X equals 1 and X equals 3. Questions for me on our input output? Okay, or our function notation. Okay. So turn to page 9 for me, if you would, please. That's the next page in your packet. we're going to do just a little more practice with this function notation and interpreting what we're seeing when we have function notation. Remember, that's an important piece of the puzzle. If I don't know what this means, then it's not helpful. So we're going to do a little bit more with that today. So for our first problem here, we have a graph of function f, which gives the height of a drone in meters, t seconds after it leaves the ground. Decide which function value is greater. So what we see here is our time in seconds and then our height in meters of our drone. So our drone has risen into the air, sort of flown around or hovered at a constant height, and then come back to the ground. Now, I want to point out this says decide which function value is greater. So as I'm looking at comparing each of these, I'm not comparing the input values. The function value is the output, okay? So I'm going to need to find the outputs for each of these and then compare those. So as I take a look at number one, f of 0, so our input here is 0, okay? When our input is 0, what's our output? 0, yeah, here's an input of 0, here's an output of 0. So I'm comparing 0 to, what's my function value at 4? 4, yeah, 1, 2, 3, 4. So I'm not comparing 0 and 4, I'm comparing 0 and 4. Does that make sense? So which of these is greater, f of 0 or f of 4? F of 4, yeah. Not because this is bigger than this, but because this is bigger than this. Let's take a look at f of 2 and f of 5. When my input is 2, what's my output? What's my function value? So here's 2, our output is 4. And at f of 5, my output is also 4. So compare these for me. They're equal. Now f of 3 and f of 7. F of 3 has a value of 4, and f of 7 has a value of 0. Which is greater, f of 3 or f of 7? F of 3, good. And then for number 4, we've got a little expression here. We're going to figure out the values of t that make it true. So this says f of t equals f of t plus 1. So what this tells me is that the height at some time is equal to the height 1 second later. So I'm looking for a stretch of time where the height stays the same from 1 second to the next. Do we have a portion like that on this graph? Do we have a section of that here? Yeah. Yeah, from 2 seconds to 5 seconds, our height is the same. So I want to start my values for t at 2 seconds here, right? Because the height at 2 is the same 1 second later, right? But 5 is where we need to be careful. That's where that stretch ends. But this is saying that if I pick 5 for my ending value, the height at 5 would be the same as the height 1 second later. Is the height the same 1 second later, 1 second after 5? No. So I have to back my final t value up to what? Yeah, I've got to back it up to 4. At 4, the height is the same 1 second later. So time values between 2 and 4 make this true, because 4 has the same height 1 second later, or my height at 4 is the same 1 second later. Questions for me on that first problem? Okay, and we're going to take a look at one more practice problem for today. So down towards the bottom of page 9, we've got example 2. For example 2, it says the function W gives the temperature in degrees Fahrenheit of a pot of water on a stove t minutes after the stove is turned on. So we're going to have something like W of t equals my degrees Fahrenheit. So let's stop for a second and think about what this graph would look like. I fill a pot with water, I set it on the stove, and I turn the stove on. What's going to happen to the temperature of the water? It's going to go up, right? Is it going to go up forever? No, it's probably going to taper off somewhere around boiling, right? Water doesn't get much hotter than that on like your home stove. Maybe if I throw some spaghetti or whatever in there, the temperature drops slightly for a little bit and then probably comes back up as the water heats that food up. And then at some point I should turn the stove off. What happens to the temperature of the water when I turn the stove off? It goes back down. Does it go down forever? No, it's going to taper off at some point. About what temperature will it taper off at? We think 72. Why do you think 72? That's what temperature? It seems like maybe that's room temperature, right? Based on some other information we have here in the problem, but room temperature, whatever that happens to be, is where our water temperature should taper off to eventually. So let's take a look at the information that we have here. W of 0 equals 72. So I'm looking to sketch a graph. The first thing I want to point out is that I get a point from this information. I get the point 0, 72. What does that point mean? What does that mean for my problem? Yeah, this is the starting temperature of my water. When I set the pot on the stove, that's the temperature of the water. So I'm going to go ahead and plot this point. It looks like we're going by 25 here, 25, 50, 75. So we should be right around here maybe for 0, 72. And now for B, it says W of 5 is greater than W of 2. What does that mean? W of 5 is greater than W of 2. What information do I have here? Yeah, perfect. The water is warmer after 5 minutes than it is after 2 minutes. I don't know exactly how warm it is at 5 minutes or at 2 minutes, but I have a relationship there. For C, W of 10 equals 212. This is another ordered pair. This is another point on my graph. So I can plot the point 10, 212. And this is telling me, we're right about there. This is telling me at 10 minutes, my water is 212 degrees. Why is 212 degrees maybe important for this problem? That's boiling. Yeah, 212 is boiling. For D, W of 12 equals W of 10. What does that mean? Yeah, we've maintained the same temperature. The temperature is equal at 12 minutes and at 10 minutes. Since I knew my water was boiling at 10 minutes, that means it's also boiling at 12 minutes. So that's another point that I can plot. I think 12 minutes is right about here, and we'll say right about there is our boiling. Okay. For E, W of 15 is greater than W of 30. What information do I get from there? Yeah, the water is hotter at 15 minutes than at 30 minutes. So that tells me my water is cooling down between 15 and 30 minutes. Again, I don't know exact temperatures, but I do know that relationship there. And then finally, W of 0 is less than W of 30. What does that mean? Yeah, at 30 minutes, my water temperature is still greater than it was when I started. So I know at 30 minutes, my water temperature is more than 72 degrees. I don't know exactly what it is or how much more. I just know that it's more than 72 degrees. So let's go back and sketch in some possible points for the times that we've kind of skipped over here. Again, I don't know exact values, so I'm just plotting what I think sounds good. If you plot your points a little differently, that's okay. For W2 and W5, our water is heating up, so I think it would be safe to say that W2 should be at least 72 degrees, right? It would be unusual for me to put water on the stove, turn on the heat, and then the water get colder before heating up. That would be weird. So W2, for 2 minutes, my water temperature should be at least 72 degrees. I'm going to put it just above 72. Maybe you have like the turbo burner on your stove that's supposed to boil water really fast, and so it's actually up here for your stove. I'm going to guess that it's only gotten a little bit hotter in that time. And then W5 has to be above wherever I put W2. Now, again, maybe you have that turbo burner and your water temperature is way up here already. I'm going to put mine in here somewhere. Okay, you don't have to put yours exactly where I put mine, as long as it's in a range that matches the information that we have here. Now let's talk about when our time is 15 minutes, 30 minutes, and 0 minutes. I'm going to start with the 30 since I've got two different pieces of information there. I know it has to be greater than our initial temperature, so it's got to be more than 72. I don't know how much more, so I'm just going to pick a temperature that's greater, but still less than my 212, right? I know my water had started to cool, so it's got to be less than 212. I'm going to pick to put it here. I'm going to say maybe we're just under 100 degrees. Maybe you think it's warmer, that's okay. Maybe you think it's a little cooler, that's okay, as long as it's not less than 72 degrees. And then finally, I'm going to plot where I think the temperature may have been at 15 minutes. The only thing I know is that it's got to be greater than my temperature at 30 minutes, and it should reasonably be less than, or it should be at most, I'll say, at most 212. It would be odd to have our water on our like regular old stove in our house skyrocket to like 400 degrees. That'd be weird. So I think it's probably in between these 2 points somewhere. I'm going to put it here. You could put it lower. That would be fine. You could put it a little higher. That would be fine too. So I've got a couple different points representing some definite times and temperatures and representing some possibilities. Because time and temperature are both continuous variables, right? My water at some point reached every temperature between 72 and 212. And my time, as the seconds or milliseconds or whatever my watch can count, ticks away. I know I've hit every time in between the ones I've listed here. I'm going to go ahead and connect these. I've hit every time and temperature in between the ones I've plotted. So these are continuous variables, and I'm going to connect the points on my graph. Questions for me on our function notation or the interpretations that we did here? Okay, so we saw that function notation set that we introduced yesterday, and graph stories came back from unit 1, okay? For the rest of class today, you have an assignment on Khan Academy. It's 4 questions, as they typically are, but I'm gonna take your grade out of 3 points. So you can miss one and still get 100%. Does that make sense? Okay, your Khan Academy assignment is due by the end of our class period. You must complete it by the end of the class period. Once you finish your Khan Academy assignment, your homework for tonight is page 10. So if you finish your Khan Academy, you're welcome to start page 10 in class today. Khan Academy, again, due by the end of the class period. Your homework then is page 10.